Hello everyone and welcome back to Rushmore 3D. I'm James. Today we're going to be taking a look at the TD3, an open source project by a creator called Marlon, and this is available from moeka.eu. It's basically a device to measure the TD or transmission distance of 3D printer filament. But what is TD, I hear you ask? Well, to take a quote from Marlon's website, transmission distance is how much light passes through filament. Others may say transparency, although this is not very accurate. And this information about our filament is particularly useful if we're producing HueForge prints. Now, these are prints that are made up of stacks of layers, where the layers stacked up on top of each other create gradients of color. And knowing how much light passes through filament helps the software determine what this will look like. Now, speaking of transparency, I do need to disclose that after finding out about this project, which actually came about through looking on printables for HueForge prints to print, I emailed Marlon to discuss the project. And they were kind enough to actually offer me a discount when I purchased the TD3. And they've also been kind enough to offer a discount to you as well, the viewers. So if you look down in the description, you'll find the code, which is R3D10, and that will get you 10% off your purchase from the official website, which is of course linked down in the description. So let's take a look at the TD3, what you get and how you build it and how you use it. So you actually have a couple of options when it comes to purchasing. You can actually purchase directly from Marlon a fully assembled, ready to go TD3. So this case I have actually modified, but if you imagine that this little white dot isn't here, this would be the sort of case you receive. And I believe Marlon has a couple of color choices. You would receive the PCB itself. Now this is fully populated with the LED ready to go. Basically one PCB, really simple. Put it in the case, as I'll show you in a minute. Maybe update the firmware and you're ready to go. So you will need to provide a USB-C cable, but if you've got a modern phone, you probably have one of these cables. So you can buy it fully assembled. The other option you've got, which is what I did, was to purchase the PCB on its own. Again, fully assembled, effectively ready to go. I just then printed the case. So what I actually did is, you see that I've got this little white dot here. I'll explain what that is and why it's there and how I did it later. But it's basically just three parts. And this part here, which is where the filament will pass through and the LED will go, this has to be printed in black. That's important so light doesn't leak out basically and doesn't affect the readings. So that's the second choice you've got. Now in terms of price, the price varies between about £20 to £40 plus shipping, depending on the option you take. So obviously to buy the TD3 assembled is a little bit more expensive, and buying the PCB on its own makes it a little bit cheaper. So there's actually a choice when you purchase the PCB to include a color sensor. Now I should stress that this currently isn't usable with the firmware that's on here. That's a feature that Marlon hopes to implement later. So think of it as buying a product that you will have the hardware for when the firmware is developed and gets there. Now I chose the PCB on its own with the color sensor, and for me that was £25 plus shipping, which was to the UK £6.50. Now these ship from Germany, from Marlon himself, and it arrived to me in less than a week. So that's your choice for purchasing from Marlon, but you actually have a third choice. As I said, in the opening, this is an open source project. So all the files you need, the PCB files, the information about the sensors, etc., is on the GitHub. Again, link down in the description. There's a 3DMF file for the case on printables, or the CAD is available in Onshape. So you can modify it where you see fit. And that's the great thing about this project, is that it's open source, and hopefully, you know, things will develop with other people putting a contribution in as well. But that's the sort of thing that can happen with open source projects. In terms of cost, this is actually a cheaper alternative to the other options that are on the market. And there's also no additional license required if you do choose to self-source the project. So yeah, that's really good. So let's now take a look on how you would assemble a TD3. Okay, so once you have the parts for the project, you need to assemble the TD3. So let's have a look at that. And I should say that Marlon actually provides really good documentation with this. With your order, you actually receive some instructions, some written instructions in your package, and a little personalized welcome note on the back. Now this link here is also really important. That's where you'll find a written, or the guide online with pictures, which are really good and help assemble these. But I'm going to show you how to do it as well, so that you can do it yourself. So let's first have a look at the printed parts. So like I said, there's just 3 parts: the bottom, the filament guide, and then the lid. And as I said, I modified this lid because this is the area on the PCB where we have an RGB LED. Now the original design for the case would be just a single layer of whatever color you choose to print your case in. So if you was to choose a black case, for example, the color that you see through there is not going to be that clear, depending on what color the LED is showing at the time. And the color of the LED actually changes depending on events that are happening when you're using it. So start up, for example, is yellow. Going to green indicates that it's ready to receive a filament sample. And yeah, so there's different colors. So to do this, all I did in Prusa Slicer was add a modifier within, just on the print bed, then lined it up into this circular feature and down to the bed. And then all I did, because I printed this on my tool changer, was tell Prusa Slicer to do this modified part in a different extruder, and that extruder had white filament loaded. So basically all it did was a single layer, white little dot, and that corresponds to where the LED will be. Really simple to do. Great feature of Prusa Slicer there to add a very quick modification. So yeah, so that's our printed parts. And then the PCB itself comes in an anti-static bag, obviously, as you would expect. And then it also has this little printed part here. And this printed part is actually made from PHA. So it's a more compostable filament than PLA. So this is just used for shipping to protect the wires. So you can remove this and just throw it in the normal bin, the trash, and that will recycle. So the first thing you want to do is to actually straighten out these LED wires, because we're going to be having the LED on top. So we just need to straighten those out. And then what you want to do is take the bottom of the case and just drop the PCB in. So the case has got these slightly raised areas, and this will mean that the PCB sits in just down there. Just move those. And the USB-C port lines up and we're good to go. We then take our black piece, and it's really important here to get this the right way around. So we want it this way around. There's a small notch here, which is where the cables are going to go. But what we want to do is get the LED right to the end of the printed part, and then just gently push it down. Doesn't need to be, don't need to push it hard, and it doesn't matter if there's a slight angle here. It's basically just to hold the LED. And then what we want to do is just slightly bend these wires so that the piece is pointing in this direction. And then we need to put this onto the PCB. Now it has to line up. I'll try and show you what that looks like, but it has to basically lay on top of the two sensors. So be careful when putting this in, and just carefully, it might be a little bit of a tight squeeze to get it into the case. But once you've done it, it just sits there like that, and then we'll just manage these cables a little bit to push them out of the way. That's it really. And what you can do, if you take a piece of filament, you can then, just to make sure things line up, is to push it all the way through, and then now that is lined up the filament hole. Then we can just take this case again. We've got this cut out here, and then that just sits on top, and then that is our TD3 built. So I think the case might benefit from having sort of a clip for the lid. In reality, it won't fall off. It's on there now, but maybe a clip mechanism for the lid might be a good feature that someone could add. Again, open source, remix it, and that will benefit other people coming to use it later. So once we have this done and installed, it's now necessary to ensure that the firmware is the latest version. So I will now show you how to do that. But yeah, very simple way to build the TD3. Okay, so now that we've built our TD3, we just want to make sure that we're running the latest version of the firmware. Before we do that, I just wanted to show you this page on the website for the project. This is the page that the link that I show you on the written documentation takes you to, and this is the detailed build guide that Marlon has made, and I just wanted to show you this because I thought it was really good and worth showing that Marlon has really thought about the process of other people buying his project and putting it together. So yeah, pretty good build guide. So the next thing we want to do is basically click this getting started link, and this is going to talk us through the process of connecting to the TD3. But before we do that, we want to make sure the firmware is updated. So we click this link here. Now this is about to open a window that the capture software is not going to show, but all that window tells you is that the device is connected to the laptop or the PC. So all you would do is just click device and click connect. So that's basically that's explained here to you. So I will connect up a USB-C cable to this TD3, and then if I click the connect button, this has brought up a window. I'm just clicking that device and then clicking connect. The web page then updates and says you've successfully connected to your TD3. So we can now just click the flash button. This is now going to download the latest version of the firmware and proceed to flash it to our TD3. Now once it's done that, it will reboot. And you can already see the case with that white dot is showing the exact color of our RGB LED. So I'll explain in a second what the purple color means, but what that will do is now reboot the device. It's now finished updating and is now rebooting the device. We've now successfully updated the firmware, and we can now look at how we use the TD3. Now you might be asking yourself, how do we actually get the TD value of our filament? The TD3 has no screen or readout to speak of. Well, it's actually a Wi-Fi enabled device, and we use a web interface to collect our value. To access that web interface, you have two options. The default option, when you buy the PCB or flash firmware to it, is the hotspot mode. And what that means is that when you start up the device, the LED will be yellow and then turn to purple, indicating that the hotspot is now live. So to connect to that, what we do is we go to our network settings of our laptop or PC or even a mobile phone, and we connect to a network called TD3. Once we've done that, we can just open a browser and navigate to the IP address shown in the Getting Started guide, and that's the same for every device. So if we go over to that web page, we can see that we've got our interface. But you also have another way to connect to the Wi-Fi. You can actually add your own Wi-Fi details to the device, and so you can connect to it on your own network. And to do that, you would have to connect up to the hotspot first, and then just click this Wi-Fi config button. And here you would enter your Wi-Fi SSD and password, and that can be found on your home router. What you would then do is click connect button. That would then restart the device. The LED would be yellow, then turn to green, indicating that it's connected to your network. So you would then need to find your new IP address in your router's device page. And then you'd basically have the same interfaces that we've just looked at. So what we can do now is that we can actually insert a filament. So let's choose this orange one, and we can just insert it into the hole on the side, and you'll notice that the LED has changed color. I'm not sure how well that will show up on video, but that's gone from purple to blue. Blue indicates that it's taking reading, and you can see on screen the value 1.64, and that, as you can see, it fluctuates. That's because it's taking a live reading. It's taking measurements and just reporting it back straight away. So we can actually take, if we take this one out, you'll see the LED goes back to purple, and the screen tells us that it's waiting for filament. So let's put this yellow one in. So we insert it, LED turns blue, and our value is being shown. And we can basically read TD value and do whatever we want to do with that. So now that we have an assembled TD3 and can find the TD values of our filament using the web interface, of course we can use these manually now within HueForge. But wouldn't it be cool if this was integrated? Well, it's currently in development, and I'm told it will be released very soon. That's the great thing about this project. Marlon is actively developing it, and because it's open source, others can too. So more features could come in the future, such as using the color sensor, if you choose to add that option when buying, of course. And one feature that is currently available is spoolment integration. Now, spoolment is a filament management solution, and I currently have a database of this running on a Raspberry Pi. I can actually bring up my database here. So this is a database of all the filaments that I currently own, how much weight the spool was originally and how much is remaining. And what we can actually do is integrate TD values into this. So you can see here I've got a couple of TD values already listed, and these were done automatically through the web interface. Now, it's a little bit out of the scope of this video to show you how to do it, but it's all in the documentation in the Getting Started link. Possibly I can do a video later when HueForge is also integrated, and we can look at all the options we have for using our TD values. If that's something you're interested in seeing, let me know down in the comment section. And when those integrations are all out, then it's something I can think about doing. Okay, so there we have it. An introduction into the TD3, a great open source project being used in 3D printing. I will now start using this device to catalog all my filament TD values, and then I can start creating HueForge prints using those values. Don't forget to check the description for information about the project, the GitHub page, the website, and of course the shop if you would consider purchasing one, along with the code for 10% off, which is R3D10. Thank you for watching. If you liked this video, please consider giving it a like, and if you haven't already done so, please consider subscribing to my channel. Hopefully I will start making a few more videos. We'll see. Yeah, thanks for watching and keep on printing.